I want to talk about log scales. When I see a visualization like this, where all the points end up clumped down at the bottom or off to one side, and then there's a sparse distribution of points throughout the space, it makes me think that maybe this phenomenon follows a power law distribution. A power law is a functional relationship between two quantities where a relative change in one quantity results in a proportional relative change in the other quantity, independent of the initial size of those quantity. So it's a scale-free phenomenon. One quantity varies as a power of the other. This is related to the 80-20 rule, or the Pareto principle, which states that roughly 80% of the effects come from 20% of the causes. The Pareto distribution is a power law probability distribution. This was originally applied to describing distribution of wealth. For example, 80% of the wealth of a society is held by 20% of its population. But it turns out this kind of distribution pops up everywhere in all sorts of data, all sorts of phenomena, including the sizes of human settlements like cities or countries, distribution of internet traffic, values of oil reserves, stock prices, size of sand particles or meteorites, severity of casualty losses for certain lines of business, or, in our case, migrant deaths. Is it true that 80% of the deaths come from 20% of the incidents? Coming back to our visualization, which seems to follow a distribution like this, we can tease out that distribution by using a log scale, in this case for our y-axis, total, dead, and missing. But how do we go about doing that? Well, I'll start by forking this visualization. I'll rename it to include log scale in the title. And then over in our index.js, instead of using scale linear from D3, we can use scale log. In the D3 scale package, there are a number of different scale types, including continuous scales. A linear scale is one type of continuous scale, and a log scale is another type. Log scales are similar to linear scales, except a logarithmic transform is applied to the input domain before the output range value is computed. Now that we've imported scale log, we can use it in our code when defining the y scale. So instead of y scale being a scale linear, it's going to be scale log. It turns out we're getting a bunch of not a number values. My guess is that this is because the extent includes or crosses 0. Let's just check what is that extent by saying console.log extent. Yeah, it goes from 0 to 1022. This is problematic because log of 0 is minus infinity. Therefore, a log scale domain must be strictly positive or strictly negative. The domain must not include or cross 0. All right, so where do we go from here? The way I like to usually solve this is to replace 0 with some small number, like 0.01 or 1 or something like that. In our code, when we set the domain of the y-scale, instead of using the extent of the data, we can go from some small number like 0.001 to the max of the data values. Now we're getting some spread, but we've got this huge gap of empty space between 0.001 and what looks like 1. So I think I'll just use 1 instead of 0.001 as the smaller value of our domain. All right, now we get a nice spread of points across the y-axis. Now, our main problem is that we've got too many labels for our tick marks. Luckily, log scales have a tick format function. If there are too many ticks, the formatter may return the empty string for some of the tick labels. Let's see if we can make use of this. In our code, the y-axis is being rendered by our axis left component. I think all of these lines look cool. The only issue is with the text, which is rendered right here. Let me try just passing tick value into yscale.tick format. This doesn't give us any ticks because it's actually not being invoked correctly. When you call tick format, it returns a function that you can then pass in the tick values. All right, now this is working. We're not getting overlapping ticks, but we are getting ticks in this format, which I find kind of weird. 3e+1. I don't know about you, but I can't really read that. That doesn't really make sense to me. I would much rather see 300 or 3000 or whatever that is. So here's the idea. What if we use that format function to tell us whether we should put the tick there or not? And if we should, just use a normal number. What I'd like to do is conditionally render this text. We can use the return value from this expression as a trigger of sorts. I'll put this text block in curly braces, and using the ternary operator, we can say, if there is a tick value there, then render all this text. Otherwise, return null and don't render anything. And then I'll reformat that. Now, if we just pass the tick value raw into the body of this text element, there we go. We get these nice tick mark numbers. Sweet. Now we have 1, 2, 3, 10, 20, 30, 100, 200, 300, and 1000. All right, that looks pretty good to me. That's how you can use log scales.